Thank you, everybody. I'm Tom Dyson. My pronouns are he, him. I was one of the founders of Torchbox, which I think is maybe one of the biggest Django teams in the UK. And I'm very proud to be the colleague of Esther, who just gave a wonderful talk. If you would like to be Esther's colleague, Torchbox is hiring. We're also the company behind Wagtail, the open source Python CMS. But this talk is about my favorite database, SQLite. I'm going to try to remember to call it SQLite, not SQLite, but I might flip between them. I actually, I wrote the proposal for this talk before I'd done the research on it. And so I have had a nervous couple of weeks, just worrying that actually SQLite really isn't suitable to be used in production. But I'm relieved that in most cases, having done the research, my hunch has been backed up. So I'm going for it. So you might recognize some of these lines. Anyone recognize these lines? Yes, Carlton. So they're from the Django docs. I've been ignoring them for a few years, and ignoring them is something that I used to feel guilty about, like debugging using print or not writing tests. But gradually over the years, I have learned not to feel ashamed about using SQLite. Initially, thanks to Simon Willison and his inspiring work on dataset, but then on from my own research into the misconceptions about this database. So the short-term goal of this talk is that you won't feel guilty or ashamed about using SQLite either. And the medium-term goal is to change the official position of the Django community. So just leading on from the last paragraph of these docs, I want to be clear that I love Postgres. I think Postgres is a miracle of modern software. It's a shining beacon in the world of open source. It gets better and faster every year. There's no dramas, no hype. Postgres has overtaken corporate megaliths like Oracle. It runs on a Raspberry Pi or a mega cluster. I like to imagine the authors of Postgres just calmly observing the rise of web-scale, next-generation databases like MongoDB, and then quietly adding JSON support and becoming the best option for document storage. Torchbox adopted Postgres about 20 years ago at a time when MySQL was in its ascendancy. It was more by luck than judgment, really, but we've never regretted it. And yet there may be times when SQLite is a better alternative. Here is a question whose answer may surprise you. And some of you have helped me answer it. I asked people on Discord to run this bash script, which ChatGPT wrote for me, and to report back with the numbers. If you have a laptop open now and you can read this on the screen, and you have 5 minutes, then you could try it. The results that have been sent in range between 800 and 8,963. Shout out to Bartek G. Bartek, are you in the audience? Bartek had the 8,000 result. And that's because SQLite is used in many of our desktop apps, like Dropbox and Spotify, and also your browsers and your browser plugins and bits of the operating system itself. But it's also used by the apps on your phone and on your smartwatches, although these are harder to count. So we can calculate a little bit. So the average number, I think, is roughly about 2,000 for the people who answered. So 2,000 SQLite databases per laptop. I think about 500 per phone from the research I've done, maybe 50 per watch. And now I'm imagining that of all the people here, almost all of you have laptops. I would say all of you has a phone. Maybe 1 in 10 has a smartwatch. So then the total number of SQLite databases at this conference, roughly 350 people, 806,000. So that is a lot of little databases, just quietly hanging out there, waiting for you to ask them questions, just really staying calm. And although actually, when I say little databases, as a point of clarification, SQLite databases don't have to be little. Does anyone know the maximum size of an SQLite database? It's 281 terabytes. So I doubt many people have pushed that limit. So SQLite is everywhere. And according to the official website, it's only second to libz, the C library for compression and decompression. So I think we can say that SQLite is in production. But apart from being one of the world's most widely used pieces of software, why would we use it? It's also famous for its test suite. I thought with Wagtail we were doing pretty well. I asked my colleague Matthew to crunch some numbers for me earlier. For every 2 lines of code with Wagtail, we have just over 1 line of tests. But for SQLite's 155,000 lines of code, they have an extraordinary 92 million lines of tests. That's a ratio of 1 to 570. It's legendary in the world of software engineering. It's so huge that they have to have many slices of their tests so that the basic ones can be run more quickly. OK, so apart from SQLite being the most widely used and rigorously tested database in production, why would we use it? I think simplicity is the reason that I have continued using SQLite, despite the official warnings from the Django docs. And on a more philosophical point, I feel like simplicity is a value that software developers can lose sight of, because perhaps making complicated things is fun, and maybe because we are unintentional gatekeepers of the complicated things that we've had to learn over the years. As an example of this, maybe you in this room, the many Postgres experts here, maybe you know off by heart the commands to do all these things in Postgres. I have done them hundreds or maybe thousands of times, but I would still look it up now. On the other hand, if I have to carry out these actions for an SQLite database, I know the commands already. I can deploy with SCP, I can delete it with RM, I can rename it with MV. Sharp-eyed SQLite users may be thinking, may have spotted some flaws in this, in particular CP. If your SQLite database is under active writes and is very busily used, then copy isn't completely fail-safe, and in that case, you should use the .backup command, which waits for writes to finish before it does the copy. But generally, I think you see the point that because SQLite databases are contained in a single file, we all know how to work with them. I know it's a bad presentation practice to put up a wall of text, but there's so much that's relevant in this blog post by Ben Johnson that it was quicker for me to point you at his words than to make up new ones. I just want to highlight the parts here that all the wonderful features that Postgres includes make it more difficult to understand the software that you're running and create more documentation to be comprehended. And while SQLite has a small subset of the features, in many cases, that subset is everything that you need. Incidentally, Ben Johnson, the author of this post, is also the author of Lightstream and LightFS, which I'm going to come back to later. The next thing I want to talk about is vectors. Vector databases vector support is the hot thing in databases right now. And vectors are important because of large language models, and because large language models have small context windows. So that means that when you ask a question to ChatGPT or one of the other large language models, there's a maximum number of tokens, which is roughly like 1.25 words per token. No, 1.25 tokens per word. There's a number of tokens they can take in. So you can't easily give a large language model an entire code base or a huge book and ask it to answer questions about it. So the solution to this, which is kind of rapidly becoming a standard approach, is to chunk up your content, split it up, and to put it into a database, and then to run similarity searches on those chunks. So you ask your question, then you find out the top 5 most similar chunks to your question, and then you supply the large language model with those chunks. We don't need to get into the background of that now, but the point is that vectors, so this way of storing the numbers, the embeddings, of which are representations of words, turns out to be something that's really important in this new world of working with large language models, and that kind of natively most database engines don't work with them well. So we have new products like Pinecone, Weaviate. My prediction, for what it's worth, is that Postgres, again, will hoover up vector use cases. And maybe options like Pinecone and Weave8 will fall by the wayside. But right now, SQLite is also a solid option for this. The way I initially started playing with large language models, again through Simon Willison, was his dataset FAISS, F-A-I-S-S library, which I recommend is the simplest possible way of doing similarity search with vectors. And since then, there's a new SQLite tool, SQLite-VSS, for vector search, similarity search probably, which does the same. So these are really good options for handling vectors. Okay, moving on from something really small to really big. Climate change, I'm not going to preface this with, in my opinion, climate change is the biggest crisis that has ever faced humanity. And while you know, thinking about that crisis and then comparing our database options in Django feels absurd, I do think that climate change should factor into every decision we make. This is me at DjangoCon Europe in 2017 in Florence, a city almost as beautiful as Edinburgh, where I gave a talk on serverlessness. I predicted that we would move, as a community, we would move to the serverless model for hosting our Django applications for reasons of efficiency, cost, and climate, which are all directly related. 6 years later, I think that prediction is looking pretty shaky. Maybe a few of you are using tools like Google Cloud Run or AWS Lambda. Any hands up for serverless users? 2, 3, 4, 5. Pretty small proportion. It's not the dominant model. My prediction was wrong. I imagine that's partly because serverless databases are hard. So if your app is running a database, and probably 99% of the things that we build in Django are, then the serverless model only gets you so far. There is an interesting approach from a new platform called Neon, who are doing some really interesting things with serverless Postgres. But essentially, this is a hard problem because cold starts are less acceptable in an environment where you need to have good latency. On the other hand, SQLite is the original serverless database. I wrote this line. This is an example of a line that I wrote before having done the research, just as a joke, really. But then I thought I should look it up. And it turns out to be true, and actually more true than I could have hoped for. I looked in Fossil, which is the source control tool that SQLite uses, and it was in 2007 that they published their page, serverless. I don't think serverless was even a term in 2007. And anyway, and I know this word serverless is something that people feel uncomfortable about because, of course, there are always servers. They're just kind of managed by somebody else. In this case, I think SQLite truly is serverless. Just to kind of to bring this point home, you could think of a traditional relational database server as a school or a university, like Edinburgh University here, with teachers, support staff, heating, lights, all ready and waiting to help you. And an SQLite database is just more like a book sitting on your table, just taking up a bit of space, waiting for you to open it and find stuff out. I know this analogy breaks down pretty quickly, but it's an important point. Imagine if all the 802,000 SQLite databases in this room all needed a few watts of energy each. We'd need another power station to run DjangoCon. Do you, in your apps, do you have universities that you can replace with books? Okay, so I know what you're thinking. We get it. So SQLite, it may be the world's most popular and rigorously tested software. Okay, it's wonderfully simple to use. It's already built into Python. It can handle vectors, serverless databases, will save the planet, yada, yada. But when is he going to get to the good stuff? Okay, I hear you. SQLite is really, really fast. I don't really understand the ways that the underlying query engine is fast compared to alternatives. The bit I understand is that because it's embedded, there's no latency. So when you make a query to a traditional database, you have to serialize your query, you have to choose the right protocol, send it across the wire, unserialize the other end, backwards and forwards. Computers are really fast, and networks are fast, but there's a little latency there. And then if your application server and your database server are in the same building or the same data center, then you have the pesky speed of light problems to deal with. All of that goes away with SQLite. And the result is that simple select queries, the type that fit in memory, tend to be measured in microseconds, not milliseconds. Sometimes it feels like it hasn't worked because you hit the button and it replies so quickly you think there must have been a mistake. And this leads to some interesting behavior changes in the way that you write software. So a kind of classic thing that we, as Django developers, worry about is n+1 queries. So it's something that's really easy, an easy mistake to make when you're using an ORM. And maybe one of the first things that you do when you think your application is running slowly is turn on Django debug toolbar, look for your queries, see which bits might be creating n+1 queries, drop in the right select related, see the query count fall. It's not really a problem in SQLite. For lots of little queries, the performance may even be better. In some cases, the recommendation is to actually refactor your app so that it runs lots of small queries. And sometimes, feels a bit sort of heretical, but sometimes that can lead to a better approach. It can mean that you're kind of decoupling or you're correctly containing the logic. So you don't have to think about combining all your queries to create the page. You can just think about the queries that are generated for each part. The first time that I think I really experienced this sort of viscerally was when my colleague Tom put up a demo of something called Bakery Demo. This is like a standard Wagtail instance with a few bits of content in that we use for testing. And he ran it on fly.io, but it could have been anywhere with SQLite in the background. And it just felt different in a way that I hadn't experienced before. So this was not an all scientific test, but it's just something that was just immediately noticeable. And Tom's figures on it were actually sort of less striking than I expected, 85 milliseconds rather than 150 with Postgres. So 150 is really fast and plenty fast enough, but SQLite on the same pretty classic Django application just felt different. Okay, so now let's get into the tricky things. What about concurrent writes? This is the first thing that people always worry about. This is why SQLite's not going to be appropriate for my database. Well, since 2010, this probably hasn't been the problem that you think it is. There's a command, this pragma command, where you turn on write-ahead logging. This is a different way of journaling, the non-standard way. And there's kind of quite a strong opinion that this should be the standard approach in SQLite. Interestingly, although it looks like something you might apply as a connection string, it's more like a property of the database. So you do sort of apply it as a connection string, but it's persistent. So once you've applied it, then it stays there. So one way of running it might be as part of your Docker build. And once it's in there, it's always going to have the write-ahead logging turned on. So generally, you just turn it on. That's kind of top-line advice. If you remember one thing, journal mode equals while. I had an interesting chat with Will from Colo at lunchtime, who had an issue with concurrent writes, even using this mode, and that's in line with the bad point here. So good, yes, it's faster in most scenarios, and importantly, you can read and write concurrently. Bad, while doesn't currently work over a network file system, and it sounds like the issue that Will had was to do with the way that Docker mounts, and it was processes within and without the container. There's something to be aware of. If you want to speed up writes even more, you can reduce the synchronous level. The default is 2. If you go to level 1, then SQLite database still syncs, but just at the most critical moments. In while mode, then it's recommended that you always choose 1. However, you probably don't even need any of these optimizations. In my tests, keeping strict mode turned on and with no write-ahead logging, I can update 50 Wagtail pages per second using a single Unicorn worker. And with a single worker, I don't even have to worry about concurrent writes because Unicorn will just queue them up for me. 50 requests a second is not an impressive number. But of all the massive Wagtail instances that I know about, like the main NHS website, Google, NASA, we have never seen traffic like that. We've never had anyone updating 50 Wagtail pages a second. Okay, here's another one. What about the weak typing? On the whole, For me, this hasn't been an issue. The ORM will handle it. But if you have other processes writing to the database, so I should have said upfront, so the typing is very loose in SQLite. So it could be a legitimate concern about data integrity. If you have other processes writing to the database, then this could be a concern. And again, there's an answer to this. Use strict. Strict, unlike the pragma commands, is an attribute of a table. So I like this slightly sort of snooty comment from the version notes from November for developers who prefer that kind of thing. This is how you enable strict mode. You just put it at the end of your table definition. All right, moving on. What about point-in-time recovery? So this is a legitimate concern again. If you are running a database and your data center burns down overnight and there's been a lot of data since your last snapshot 24 hours ago, then you're in trouble. This, I think, has been like probably maybe the most significant weakness for using SQLite in a sort of industrial setting up to now. But there is now a solution. So there's this guy, Ben Johnson, I mentioned before. He wrote a key-value database called Bolt, which works for Go. He now works at Fly.io, working full-time on SQLite stuff. And his project Lightstream cheekily updates. This is the SQLite strapline. He updates it from this to small, fast, reliably, globally distributed, choose only 4. And the way SQLite works is described in this diagram by Michael Lynch in his post, How Lightstream Eliminated My Database Server for 3 cents a month. It's a tiny bit of software written in Go that uses the write-ahead logging, in fact, to listen to changes and push them up to S3. So it's a tiny cost and just sort of solves this problem. For a more enterprisey example than Michael Lynch's blog post, Tailscale, who you probably know, this sort of really amazing next-gen kind of VPN-type provider, as I understand it, they run their main database now on SQLite using Lightstream. You will notice the date of this blog post, but they promise at the bottom of it that it is not an April Fool. SQLite is the solution that they are now using. All right, okay, so we're pushing on. What about horizontal scaling? What happens when I need my use case gets so big, my traffic gets so large that one server, one instance isn't enough? So first up, my answer to this is usually Yagni. You ain't going to need it, probably. Computers are fast. And it turns out that SQLite scales vertically very well. Expensify, this blog post here, they have this famous blog post where they show 4 million requests per second into their SQLite database. Simon Willison in his load testing gets more like 500 requests per second. In my test before I said 50, which is still enough for me. So you're probably not going to need it. But if you do, then again, Michael Johnson comes to the rescue with his LightFS project. This is in beta at the moment, and it's a bit more complicated than the Lightstream. And essentially, it's like a sort of replacement file system that handles replication for you. I'm not going to read out what it does because you can see it here. My colleague Tom Usher, the one who showed the really fast example, has written a good case study of how to do this, and which is a much more kind of practical level using Django. And if you're interested in LightFS, this is the resource that I recommend. So I'm coming to the end now, and my request really is that if any of this sounds reasonable, and you're interested, the simplicity of SQLite appeals to you, that you help by continuing the work that Simon started at the DjangoCon, the last DjangoCon in the US, by load testing and sharing the results. I've also, because like everyone, I suffer from not invented here syndrome, I've made my own load test, which you could try as well, but I think Simon's is probably the best place to start. And finally, if you don't take anything else away, journal mode equals while. That's my top tip. And I hope that you will all join me in embracing SQLite as a production database of the future. Thank you.
Thank you, Tom. That was a great talk. Any questions? We have time.
Yep.
Hi, thanks. That was wonderful. And we use SQLite at work in production as well for a few things. One of the things we've been struggling with recently is that depending on developer machines like Windows, Mac, Linux, depending on Linux OS versions, how do you make sure people use the same SQLite version? Because then in the deployed environment, it's yet another one. And that's been a bit of an issue on our side.
Yeah, thanks for the question. I don't know the canonical answer to this, and it's something that I've been wondering myself through making this talk. It seems to me that the safest way of doing it is specifying the Python version very carefully. So the SQLite 3 library in Python, with each Python upgrade, will target the later version of SQLite. Seems to be pretty current. So it seems to me that 3.11 is targeting the latest version of SQLite, even though that's only a few months old. But yeah, my understanding is that the way to solve that problem is to be as precise as possible about your Python version. Interested to hear if anyone else has any alternative experience to that.
Hello, thanks for your talk. I thought the part where you were talking about vector databases was really interesting, and specifically used this historical example where SQLite was integrating JSON from MongoDB. Can you speak a little bit more about that kind of historical example and why we think that vector databases ultimately won't be necessary compared to Postgres or SQLite? Thanks.
Sure. So actually, my SQLite has definitely adopted JSON and has vector support through those plugins. But actually, it was really Postgres initially that when I was talking about it being the sort of beacon in open source that supported JSON and document storage in the way that tools like Mongo had. So I can't speak for how the open source communities behind SQLite and Postgres work, but it does seem to me, particularly with Postgres, that they take this quite calm approach to observing what's new and then adopt it. And one of the ways is through plugins. So actually, I was involved a long time ago in the early 2000s in an XML plugin for Postgres, and so that was available as a third-party plugin. And then two versions later, Postgres had their own, actually much better XML plugin that worked in a similar way, which meant you didn't need the plugins. And so I imagine that's one of the ways that Postgres works, and similarly with SQLite. So SQLite plugins work in quite an unusual way, where you just have to point to the file at the top of the query, which means that they're quite easy to add. As I understand it, the SQLite open source community is kind of unusual because although it's open source, you can't really submit pull requests. The author basically just likes to make the decisions himself. So yeah, I guess it's not a very good answer because I don't know how that's going to change, but from observing how it's happened in the future, it's been what seems to me quite a kind of calm evaluation of the environment and then a decision to adopt.
Thank you.
Let's have one last question.
Thank you. It was a great presentation. To be honest, I didn't use SQLite for the last 10 years or so. We are stuck with PostgreSQL. So I was wondering, how is Django's support for SQLite? As far as I remember, for example, this distinct function wasn't working because of the limitations of the SQL. Are there any change on that side, or what changes can be made to make it more pluggable?
Thanks for the question. I'm afraid I don't have a good answer on this, but others may know. My impression is that the basic ORM features are consistent across SQLite, and yeah, I'm getting some encouraging nods. Yeah, so I don't think there are any limitations for the basic features now.
Okay, thank you.
Well, Tom, thank you again. Let's give him a big applause.